Hello, everyone, and welcome to Claris Community Live. I think this is our 13th episode, and I'm pleased to welcome back Cris Ippolite and Ronnie Rios for a session to help you jumpstart using AI in Claris FileMaker. Ronnie and Cris are going to walk through everything you need to do to get started using semantic search with FileMaker 2024. And as we get started, we have a couple of poll questions just to help Cris and Ronnie know what level you all are at as you're getting started on your AI journey. And I also have a demo file that Cris kindly provided that I'm going to drop into chat. You'll just need to download that if you want to follow along in this workshop format. So while the audience completes the poll, Ronnie, do you want to remind everybody who you are?
Sure. Well, everyone, if you don't know, my name is Ronnie Rios. I am a product manager here at Claris, currently focusing on all things AI. Really happy to be here. This is probably my fourth community live, I think, at this point. So really excited about this one.
Yeah, and welcome back, Cris.
Hey, happy to be here. I'm Cris Ippolite from iSolutions. Following up our basic prompting live stream that we did earlier this year with getting into FileMaker and doing some semantic search stuff. So excited about this today.
All right, and to get to the poll, you'll need to click on the apps down in the lower right corner of the WebEx window and choose Slido. That is where our questions are being asked. And let me just see if I can get it working. All right, now it should be working, so hopefully you all can see it. And just, Cris, I wanted to have you introduce what we're going to do today and how it relates to what's going to happen at Claris Engage.
Oh, yeah, great. So today is sort of a mini version of what we will be doing as a full day as a training day session at the Engage Austin event that's coming up at the end of March 2025. You know, with the holidays coming up, it's going to be a travel planning time already. Registration is now open. So if this looks interesting to you, you will see a little bit of this, but we're going to expand this out to, a few hour version. We've got a whole bunch of other really neat stuff planned, and I'm going to have be lucky to have Ronnie as a special guest who is going to save all his good stuff for this session. And one quick note, this is the first time we're going to have training day at the end, so after the general sessions. So it'll be on I think a Thursday, if I'm not mistaken, rather than a Monday like we've traditionally done it in the past. And really, I think that format's going to work well for this. So you're going to hear a lot about some of the stuff conceptually when you're at the conference, and then you'll be able to come and do hands-on in the training day. So, and then that is, of course, why Ronnie is going to save all his good stuff for the end. So definitely looking forward to seeing everybody there. We have got a whole bunch of stuff. We'll be planning and adding stuff to that curriculum really right up to the week of the event, because of the way AI, the landscape changes so often. So it's going to be a lot of fun. I'm looking forward to it. And you can register now.
Yes, please do register now. We are almost out of the early bird discount for conference only registrations, but there are plenty of the big discount available for the conference and training day package. So please, we'd love to see you at training day and at Claris Engage. And so we've got some people have completed the poll, and let's see, the first question, what kind of FileMaker AI integration have you done prior to semantic search? About 20% have played with either the new script steps in FileMaker or done some integration using insert from URL in older versions of FileMaker, and half have none.
Good. Well, you're in the right spot.
Yep. And
we'll cover every one of the new script steps, all the supporting calculation functions. We're going to do it in a progressive, hands-on exercise. So, and we're focusing, of course, on semantic search today, because that's what the FileMaker, the latest AI features do focus on. So that's the journey you're going to be on with us here today.
Yep. And as far as people who have you experimented with semantic search in FileMaker 2024, again, half, I don't know where to start. A third, yes, a little. 5% have something in production,
Nice.
which is great. Congratulations. We're thrilled to hear that. And about 13% don't have FileMaker 2024 yet, so they haven't tried. And so, as Cris alluded, this is really a hands-on workshop style session. Throughout, Ronnie's going to introduce some concepts, and then Cris will do a demonstration. And I've asked them to pause in between all of those transitions for questions.
Yep.
So, yeah, so please drop your questions in chat, because that's primarily where we'll be watching. I'll also try to keep an eye on the Q&A panel, but it's hard to watch all the places. So please use chat when you ask questions. And with that, couple questions. For the demo, yes, you've got just a CSV data file for meeting data.
Yep.
Cris is going to walk you through using one of the FileMaker sample file meetings. So there is no FileMaker file, because you'll be able to just get started with that.
Yep. Make it as easy as possible to get started. So all you need is that CSV, and what that is just some data that we're going to use to embed. So I saved a couple steps for populating a bunch of records.
All right. Well, so with that, why don't you and Ronnie take it away?
Let's do this. Awesome. So I think the best way to get started is talking about what the tools that we have at hand. So in FileMaker 2024, right, we introduced a series of script steps and functions that are grouped together in a new category called artificial intelligence that we will definitely be continuing to expand as we move forward. And so let's go start let's look at some of these in batches. So part of those group of tools that you have in here are two script steps that help you with managing your AI account. So we've got here the configure AI account script step and the set AI calling script step. The configure AI script step allows you to set up the connections with your AI providers. Say you have Open AI, or if you're going to be communicating, integrating with a locally open source model, it'll help you set that up there as well. And so in the script step, you're going to set up, things like the account name that you want to give it, any API keys, and where the host is located. It's going to be local. The set AI call logging allows you to record detailed information about all the AI interactions that you're having. So saving logs and being able to use that information for debugging later on. So together, all of these give you everything you need to initialize, monitor, and even help you optimize your AI integrations as you move forward. We got other script steps that are these are the ones that are focused on generating the embeddings and help you manipulate them. So in 2024, we set up some tools that are specifically created for you to be working with vector embedding. So this really opens up a whole new aspect of your development so that you can analyze and process data. So we start with the insert, we have insert embedding and insert embedding in found set script step. Along with the new function as well, all of these, the get embedding function, all of these allow you to create vector embeddings for either individual records or entire found sets. And so these embeddings that you create with them, right, are really the essence of semantic search, allowing you to take the semantic meaning out of text and enabling you to create really amazing AI-driven operations. And then to kind of counter that, we've got the get embedding as file and get embedding as text functions. These offer a really flexible way to convert between binary and text formats. We'll talk a little bit more about those later, but allow you to really manipulate vector embeddings in whichever way makes more sense for you. So all of these features combined really make up a fantastic toolkit for generating, storing, and manipulating vector embeddings, allowing you to really set up very sophisticated semantic analysis and honestly AI-powered search capabilities in your solutions. Now, the fun really starts with performing semantic search, right, and doing search similarity. And so here we've got a script step and function. The perform semantic find script step allows you to search based on meaning rather than exact matches, right, or keywords as we're normally used to. So this really unlocks data retrieval in ways that were just not possible before for us. So it does this by leveraging vector embeddings to really improve data discovery by finding contextually relevant data, if you will. So complementing this, right, being able to search, you've got a new function called cosine similarity. And this function allows you to quantify, right, the semantic relationship between two pieces of data. So when you combine these, they allow you to really give your applications the ability to understand and compare data at a very deep level. So this opens up possibilities for things like intelligent document classification, content recommendation systems, and even very advanced data analysis and more things. So in short, you're now able to create solutions that are capable of understanding and processing data in very intelligent ways, which is really why I'm so excited about this. Now, you definitely want to obviously want to keep manage costs and security. And so the token management functions that we have here help you with that. So in FileMaker 2024, we also include tools to help you optimize your AI usage so that you can do these things in a more efficient and cost-effective way, right? And so you've got the get token count function. Allows you to estimate the number of tokens in a given text, which is very, very important for managing your API requests and help you predict cost as well. And we'll go deeper into these later on. But the important thing here is that these help you optimize the input length, right? So knowing how much you're going to be sending off and also avoiding any potential errors due to token limits. So complementing the get token account, you've got another function that is the get last step tokens use. This function allows to get real-time feedback of the actual token consumption of every AI operation. So again, together these functions allow you to monitor all your AI implementations, so providing you with granular control over the use of the tokens that you have for your application. And then we've got this other function, which not necessarily directly associated with AI. The getTableDDL function provides a very powerful way for generating what's called data definition language for any specified tables. And so what this helps you do is being able to create the definition of the schema in your database, so you can be able to send it to AI and be able to create more AI-driven operations. So if you ever wanted AI to create, say, SQL queries and you want to let it know what your database schema looks like, this function helps you do all that.
All right, and we are going to touch on all of these. Well, actually, we're probably going to stop short of some of the token management stuff. We'll definitely have discussions about it and can answer questions about that. But we're going to show you how to take, in this case, a starter solution in FileMaker and add in all of these features so that we can perform a semantic search. So the first thing that we are going to need to have is well, first of all, the file. So I just thought that it would be way easier for everybody to just open up FileMaker. Actually, let me just show you what I did. I went to Create New, and you'll get this window. And if you scroll just below the fold there, you'll see that we've got the meetings file. And this is the file that we're going to use in its existing state, and we're going to add on these functions and capabilities. So go ahead and select, for those of you that are following along, select the meetings starter, hit create, and I'm going to save it to my Mac, which just to make it easier to find. And here is what that file will look like. And once you get to this point, of course, since we're talking about embeddings, which is a conversion that we do against text, we're going to need some text in this file. So that is where the CSV, the meeting data CSV file comes into play. So for those, I'm going to actually give you guys a beat here to make sure that everybody's downloaded that. It's called meetingdata.csv.
And I'm
And
gonna,
that link, you can, yeah, we'll post it again just in case
yeah.
anyone showed up late.
Yep, I just posted it again. So,
Okay. And you're all familiar with doing imports in FileMaker. Nothing AI going on here. You'll go, well, it opens up to the meeting details layout. So in case you poked around, you want to make sure that you get to a, well, it's easier to get to a layout that's based on meetings. So we've got meeting details here. I'm going to choose import records, import records file. And then I've got the meeting data.csv. And over here on the upper left-hand side, you'll want to use as field names so that we can see the CSV left-hand column populated with these names. It'll also allow us over here in the upper right-hand corner to choose the matching names option, which does all the lining up of the fields appropriately for us. And don't worry about duration. That's just a calculation, so it doesn't import. So once you see all the fields or all the column names lined up on both sides and you say current table meetings, go ahead and hit import. And when you have done that successfully, you will see that it has imported 108 records. And just to give you guys a sort of an overview of the story that we're going to be doing here today, this is a meetings file, which is of course manages meetings information. And in the notes field, we have notes about the meeting that occurred. And we want to be able to add semantic search functionality against those notes so that we can do different types of searches. And I'll introduce those to you and we'll get into the nuances and a bit of the weeds there as well. So the very first thing that we want to do when we set this up is you saw Ronnie talk about a script step called configure AI account. And that's the first thing that we're going to add because it should be. That is where you will, well, that needs, and I'll get into why that's important in a second. But before we get there, you will, if you're playing along, you will need to have an API key specifically from OpenAI. You probably saw that in the email. And if you haven't gone through that process yet, or maybe if you're watching this in a recording, you can see the instructions that were in the, well, actually, they're in the community post as well, too, Rosemary. Now that I think about it, I added that as a comment a couple weeks back. But I have an API key ready. So assuming that you have one, I'm going to jump into the steps that are required to set up the configure AI account script step. So of course it's a script. So I'm going to, while I still have the meetings file open, I'm going to go into the script workspace. You see that we've got a few of the meetings scripts there. We're going to add a new script. And I'm going to call this one configure AI account. Cleverly named after the script step itself. I'll save that. And all this script is going to do is literally just run that one script step. So we'll talk about that here for a second, but I'm going to just start typing CON and you see that I get the configure AI account. Also, you'll notice over here on the right-hand side where all the script steps are, if you've got the script step pane open, you'll notice that there's a new section in FileMaker 2024 called Artificial Intelligence. And you'll notice that the old machine learning supported script step is in there as well as some of the new ones. So we're going to start off with configure AI account, and you can just put that right into the script here. And all we have to do is set this up, and our file will be able to communicate with it in an account over at OpenAI. So a couple of things about this, though. You'll notice the very first input here. You see this little blank area called account name. That is the name, for those of you that have worked with some of the Core ML features or maybe even some of the beacon features from back in the day, you might remember that there was script support for sort of turning on the ability for your application to see beacons or have access to a Core ML machine learning model. This is the exact same thing. Well, I like to think of this as sort of the switch that you flip on to allow your application to communicate specifically with with one of the AI accounts. So because you could potentially be communicating with multiple different models over on the OpenAI side or on the local model side, you're going to want to name these something that you're familiar with. So in this part where it says account name, this is not like anything about your OpenAI account. This is literally just a name that you're going to give it so that you can refer to this account in some other of the supported script steps that will ask you which of these accounts do you want to be using in like a get embedding function, for example. So I'm going to enter in sample account, again, cleverly named. And I'm going to hit OK, and you'll see that show up here. So again, the account name is not the account over at OpenAI. It is the account that we're going to use to reference this model that once it's configured and available to us within our session. So you'll see, and you'll see me reference that quite a bit in some of the exercises. Okay, so then model provider, you'll notice that we have a drop-down option here. So it's by default, it says OpenAI. Currently, at the time of this session and recording, the available model providers for vector embeddings, for example, are OpenAI, and you can also do custom. So Rosemary, I'm going to give you a chance to tee up the next live stream, because we will not be covering the custom option here because there is an entire live stream dedicated to that. Rosemary, I'll let you plug that for a second before we go to the next step.
All right, and I'm just going to respond quickly. A few people have asked me if this is being recorded. Absolutely, we always record Community Live and share them to Claris Academy and the Claris YouTube channel. Usually by Friday morning. Sometimes I get everything processed on Thursday afternoon. And then sometime early next week, we'll send all registrants a link. So even if you don't catch it because you're not subscribed to the YouTube channel, you will get email next week with the link. And yes, next Community Live on November 7th, Ronnie will be joining me again. And we'll also have Wim DeCourt. And Ronnie and Wim are going to walk through all the steps required to set up a local LLM, either on your laptop or on another server adjacent in your environment. So I'm dropping the registration link for that in chat right now. So absolutely, we hope to see you there as well.
Thanks, Rosemary. And yeah, while we're going to be focusing on using OpenAI in this case, having a local account certainly has advantages. Not only is it running locally and could be more performant for your use case, but it's also a great idea if you want to keep your data from leaving your network or your machine, because you can just communicate with a model that's local. And just to be clear, there are absolutely very secure ways to communicate with APIs, like the OpenAI API, in a secure fashion where your data does not become part of training. But in the case where you're connecting directly to OpenAI via the API, at least, not to be confused with the ChatGPT experience, that is completely different than what we're doing here today. If you use ChatGPT and you put your private data in it, it could be part of their training. It absolutely does not mean that someone could go ask for your data and retrieve it, because these are not retrieval models. These are learning models, but it could be part of the next learning or training session. And if you're uncomfortable with that, or if that violates some of your data security policies, then you either want to go with one of the secure API options, like going to OpenAI through Azure, through Microsoft is one of the ways to do that. And then it'll be excluded from the training data, and then also you'll be able to manage API gateways to secure your data and transmission, or you can do one of the local models. So that's really what the decision is when you're picking this provider option that you see here.
And
okay, so
before you move on, there's a question. Do you need to run the configure account script step every time you open the file, or how often does that script be run?
Yeah, it's like you're looking at our cue cards. Yeah, that's really the next step of this. One more thing though, before we get to when and how, I just want to. There was one really important part that we haven't finished yet to configure this, and that's the API key. So I'll answer that question in just a second. But first, just want to enter in the API key. And yes, I'm sharing my own API key, and I promise you I will be deleting it immediately after this. But that's where you put your API key as text. And so then let's address that question, because this is very important. Once you have it set up and once you save this, it's really up to you. So what that means is maybe you only have one workflow, or there's only one layout in your file, or one a script that you're running, or a button that a user presses that is going to require that you communicate with one of these accounts. If that's the case, then you can embed this script step maybe at the top of a script that's already managing that workflow. If you have various different things that would require interacting with your AI accounts, then it is a good idea to set it up as as one of your open scripts. So what happens is once you flip this switch to this specific account, that will be available to the user for the entirety of that session. So if you just want to set it and make sure it's available at all times, you can just do that as part of your open script. But if you want to just keep it so you're only turning it on when you need it, then you can just add it to an existing script, or put it within what I'm gonna be doing here is I'm gonna keep this configure AI account as a separate script, and I'm just gonna call that from other scripts. So that'll be kind of an example of one of the ways you could do that as well too. So and Ronnie, there's really no like performance consideration for why you might not want to turn it on at the beginning of your session, right?
No, not really. I think that the more important thing is really the account name, and giving you the ability to switch from one to the other. So if you do it, if you were saying, like you were saying, if you've got multiple calls, you've got multiple scripts that are going to be using this account, you can start with, say, OpenAI, and you have this configure AI account script step maybe on first window open, trigger script, something like that. And if you ever wanted to switch over to a local model, you only have to change this one script step. Everything else would remain the same. So it makes it very easy for you to move from one provider to another, from one host to another. So instead of having to track down every single little script that has anything that has to do with vector embeddings or anything like that, you go to this one configure account and you modify that, and that's it, which is fantastic.
Follow-up question. How do you, if once you run this script, it's up for your FileMaker session, would you ever want to turn it off or disable it during the same session?
It really doesn't take any resources. It's just saving some configuration in your environment memory. It's very small.
And second question, is there only one AI account active at a time?
Nope, you can have as many as you want, which is really cool because, as Cris alluded earlier, you might have different providers. And so you might be using OpenAI for a few things, maybe some local models for something else. And so you could have 3, 4, 5 of these in this one script. And again, the account name is what you're going to be using to reference the right account. And so that's important, right? It's an arbitrary piece of text, but as long as you use the same one, you'll be fine. And so you can have multiple of these, which is great. And it'll be much more important as we start adding more functionality under the AI category as well.
Yeah, I would add to that what we're going to be focusing on here today is communicating with embeddings models. We're going to talk about what that means here in just a second. But there are tons of different embeddings models. Currently, that we have access to 3 of them using OpenAI, but then through your open source models, you could find an embedding model that specializes in like pairing or classification, or is really geared towards your use case. And you might leverage all those use cases within one single file. So in that case, you would set up a different configure AI account with the account name, like Ronnie was saying, for each of those different models that you're going to be communicating with, and you can turn them on when you need access to them before you start to reference some of the other script steps that we're going to show. Otherwise, you'll get an error if you haven't turned this on already. And Ronnie, there's a question about turning it off.
There is no turning it off. It'll persist while the file is open, but again, it doesn't really take. It won't have an impact, any significant impact on your solution or any performance.
So now we keep using the word embeddings, Ronnie. Let's do everybody a favor. Let's talk about what we mean when we say embeddings and what kind of support we have within FileMaker.
That's a great question. That's a great lead. So before we start implementing semantic search, functionality into your app, we really have to kind of understand a little bit about embeddings. And I think one of the first things you have to do is figure out which data are you going to be targeting for searching, and where you're going to store the embedding data. So let's talk a little bit. About that. So you can specify. You'll be able to specify the text a text field or a container field to store your embedding data. So what happens is when you're going to choose whichever data you want to be made available for searching, and then you're going to create embedding data. You're going to pass that through. It's going to pass through an embedding model, and it'll create what we call a vector embedding. And that vector embedding can be stored in either text, or it can be stored as a binary object. And so when you specify the target for these, and we'll go over these in a little more detail, you can specify this as a text field or a container field to store that embedding. When it's stored in a container field, FileMaker will automatically store this as a binary data. In binary format, the size is smaller and it does improve the performance. So we highly recommend that you use binary. You use a container field, so you get a binary data, you get better performance. Again, it supports both text and binary, but we really want to do that. And so in order to create those embeddings, we've got a series of script steps and functions that allow you to do that. So we've got a insert embedding script step for both single record, and we also have insert embedding found set for multiple records, and then we will have a function. We'll go over these a little bit more. But just to get started, I've mentioned that you're going to put in some data. You're going to send that over to an embedding model, and that's going to create the vector embedding. And as of right now, the embedding models that we currently support are the ones that listed here. So from OpenAI, you can see that there's 3 embedding models here, and we also support several open source models. Now we've listed 4 here, the open source models. These are the ones that we've tested, we know work, and you'll get great performance out of them. But it doesn't mean that others won't work. But these are the ones that our engineers have vetted and would know that it'll absolutely work. And these are really, really great all around embedding models. Some of these are also multilingual. So if you want to be able to search in different languages, you'll be able to do those, use those as well. So let's dive a little bit deeper into the script steps and functions that you're going to need in order to create these embeddings. So let's start with the insert embedding script step. So you'll use the script step to generate a vector representation of whatever the specified input, right? Using whatever model that you specify here in the script step. So you'll have to specify a target, a variable, or a field where the embedding will be stored after that. Now, if the target is not specified, just so that you know, the script step is going to return an error, which you can capture with the getLastError function, as per most of our script steps. So important to know is that this script step saves the vector as text if you have a text field as your target, or if you choose a variable, and it'll save it as a binary data if your target is a container field. And again, binary is the recommended format. Now, if these vector embeddings are the result of this script step, the vector embeddings are what's going to be used by the perform semantic find script step that we'll talk about later to perform the actual find. You're not searching directly into the text. You're searching through the vector embedding that is the result of the script step like this one. So when adding the script step, you've got several options over here. So let's go through these a little bit. So first off, the first option you have for this script step is account name, and this should be familiar, right? This is that text expression that Cris was talking about that you added there in the configure AI account script step. So whatever name you use in that configure AI script step, you're going to want to reuse here as an option in that parameter so that it can reference the right account. Next, you've got the embedding model. And so this is literally the name of the model that you want to use to generate the vector embeddings. And so you specify the name of the model. It's just plain text. It's a text expression. And that model name is going to come over from your provider. So if you're using OpenAI, you can use one of these models. If you're using open source, you can use any of these or any other one you want, but these are the ones, again, that are supported. Next, you've got the input. And this is the text expression, right? It's a calculation. And this is what's going to be used to be sent over to the model to be converted into a vector embedding. Right? So this is what is it you're going to be converting to vector embedding that you want to be searching for later on. And then the target specifies where do you want this vector embedding, the resulting vector embedding, to be stored. Again, you can choose a field or a variable over here. If you choose a text field or a variable, it's going to end up being as a text. If you choose a container field, you'll get binary data. Once again, that is the preferred way of doing it. You get much better performance and you get smaller sizes there as well. So this will create a vector embedding for a single, record. Now, what if you've got a whole bunch of records, right? And you're just getting started like we are today. You want to get started and you want to create embeddings for a lot of records. So this is where the insert embedding in found set script step comes in place. Now, you could just create a loop with the previous script, but we thought that this is going to be an operation they're going to be doing many times. And so we thought it'd be better if we can create a script step that will eliminate the loop for you. So FileMaker does a loop for you. So this script step does exactly what the previous one does, but does it for an entire found set. So you can use this to generate vector embeddings for an entire table or the records in the current found set. It's going to use a field as an input, and then save the vector embedding into a text field, or again, into a container field. So for every record in that found set, the script is going to send the value of the source, whatever it is that you want to create embedding for. It'll convert that, get the vector embedding, and it'll save it into that target. So you might want to use this for creating vector embeddings for the entire set, or if you want to keep updating in batches. This is a great way of doing that without having to go over and create an entire loop. So there are several options here. We've got several parameters for this script step. Once again, we start with the account name, and this is the name that you use in the configure AI account script step. As long as you use the same one, it will reference that same account again. The embedding model is, again, the text. It's just a text expression, which is the name of the model you want to use. Again, you'll get that from your model provider or from the open source model that you downloaded. Then the source field is going to be the field that you're going to be using to convert convert into a vector embedding. So this is whatever text field that you have in your database. By the way, if the field is empty, nothing gets sent over. So there's no issues with that. So we'll jump over or ignore any empty fields it might have. Then you got the target field. Just like the previous one, you can specify either a text field or a container field. If you use a text field, again, the resulting is going to be a text representation of that vector embedding. If you use a container field, you'll get a binary result, kind of like a little file in there. Then there's another option, a couple of options here that are really interesting and different than the previous one. The first one is replace target content. And this replaces the field contents of the target field if there's anything there. So this is great if you want to update a vector embeddings in batches, right? So if this option is off, the vector embedding is going to be added to the target field only if the field is empty. Otherwise, the field is left completely unchanged. So turning on this option is useful if the contents of the source field changes frequently and you want to keep on updating that. It's a great way of doing that. And the final parameter here it's called literary parameters. And this is a text expression. It's really cool. It's a little JSON object. And it'll help you specify some additional parameters that are supported by this script step. It allows you to do things like set limits on the size, the number of calls, the frequency of the requests that you want to do. So you could use this to optimize your script depending on the amount of data that you have or the model you're using, or maybe if your provider has some limits, especially on tokens or any technical specifications on RAM and things like that. So there are several parameters that are supported. This is a list of the parameter keys that are supported in that JSON object. We've got an example of here what it might look like. But it's really cool that you can play around with these settings, and these override the internal default parameters that we have for this script step, which is really great. Again, if you want to optimize things, especially for your particular environment in there. All right. Lastly here, for generating embedding, we've got a function, and this is really interesting. I really like this function. So the get embedding function, just like the previous two script steps, allows you to generate a vector representation of the text data that you provided, right? Using a selected model, any particular model that you've specified, and again, returns a vector embedding. Now this function, as opposed to the other script steps, only returns container data, right? So it will not return text as a result of running it. So similar to the insert embedding script steps, right? It generates an embedding vector for whatever input you got with a specified account. So the parameters here, if you got an account, it's again the same account name that you use in the account in the configure AI account. You're going to use that there. Model is the name of the model. It's text the text name of the model that you're going to be using, and then text whatever text that you want to create an embedding for. Interesting enough, so it's just like, if for calculations and tracking down errors, if there's no AI count that is currently configured by the name that you specify there, this function is going to return a question mark, and you'll be able to capture that with error code 877, which is, can't find AI count. So you'll be able to trap for errors there. Good. All right, there are two other functions that I want to go over very quickly as well. And they allow you to manipulate the resulting vector embeddings. So the get embedding as file and get embeddings as text, these are counters to one another. These functions allow you to convert vector embeddings between text and between binaries. So we've got script steps and functions that can create vector embeddings on either text or binary. And so you might find yourself in a situation where you need to convert it from one format to the other. It's possible that maybe you've got already embeddings from some other API and they're in text format, it's the JSON array, and you want to convert them into the binary format that's better suited for FileMaker, or vice versa. And so these functions allow you to make that conversion. So they're very helpful, again, for maybe exporting vectors for outside use of FileMaker, or importing right into FileMaker. So they're very useful, very straightforward using. So again, using these script steps allow you to generate and store embeddings in binary format. It's a lot more compact and very much more optimized for performance. But the input of these are very simple. It just provide either the text representation or the binary, and you'll be able to convert them back and forth.
All right.
So I think that's a pretty good overview of these, Cris. I want to see them.
We're gonna put
we
these
got
to
some
use.
questions.
Yeah, let's address some questions before we jump into applying some of these.
Yeah. So first, this actually I think relates to the last question. You set up the configured AI account. How do you know if that script step was successful, if you've successfully accessed OpenAI or your model?
That error message that Ronnie just mentioned, the specific error, you could check for an error. Let's see. Well, actually, when you try to run any of the script steps that Ronnie just went through and it's not configured, you'll get an error code 877 back, and that it will give you the text of the status of can't find AI account. So much like you do, you try to see if you're online, and then you see if you get a specific error back to determine whether you're online. It's the same kind of thing, same kind of process that you can apply here.
Okay, and for
also it won't work. It's the other way you'll know.
So when you store vectors as a container, is there a performance impact for storing those as external containers or internal containers, and do we have a recommendation for that?
Yes, there is a slight performance decrease if you do it externally, just like with any other container data, right? So there is slight. It depends how big that is. It's going to depend on your particular environment and your use case, but ideally you want to have them stored internally in the file. I've heard people already doing some tests on where they're setting this up as a separate file just for embeddings, and I think there'll be some other information coming out as best practices. But short answer is you'll get better performance if you store them internally.
And and you'll get better performance if you use the container versus the text. I
Yes.
already mentioned that a couple of times. We can't mention that enough.
Yeah.
All right, yeah, that goes to the next question. One just came in. Is there ever a situation where you'd want to save the embedding as text when you're using FileMaker?
You would specifically be doing that if you want to use it outside of FileMaker, if that helps make sense of that. Because you'll be storing it in FileMaker, and you will need to store it in FileMaker to be able to leverage semantic search, which is what we're going to add into our exercise file here. But if you have other uses for those embeddings, like if you want to store those in a vector database, for example, that's external to FileMaker, you can export the embeddings that you already created.
The only other use case is as I did it the first few times I did it, I was just curious. I wanted to see what they look like.
Yeah, it's worth taking a look. And I'll talk a little bit about how much that data, what kind of data we're actually talking about there. So it's actually pretty significant. So really what we're talking about doing here,
Hold on.
and one of the questions also was, when would we use an embedding function? And that's what we're going to get to in the exercise. So go ahead if you have more questions, and then I'll jump back
Yeah,
into
so I think the last
exercise.
one I'm going to ask now is if you're in a multi-user environment, um, are the embeddings shared across all the users, or does each user have to create their own embeddings?
It's a field.
It's a field,
Okay.
just
So,
like any other ones. Yeah.
Which is useful. There won't be a lot, once you really kind of get familiar with this, there won't be a lot of scenarios where you're just embedding for your own use case, although I will specifically address in our exercise a situation where you might want to embed something that is only specific to your session. I'm gonna talk you guys through the steps on how to do that. So in general, though, once you've created the embeddings for your fields, like we're going to do here, you will likely want to keep those stored, because there is an overhead to actually creating the embedding. There's a little bit of performance, but it actually costs something too. I guess not in the case of open source, but there's a compute overhead there as well too. So once you do an embedding, you want to keep those in there, unless you think maybe the value has changed. So for example, in our case, these notes fields that I have here is what I'm going to embed. So if I think this notes fields has been updated or has changed, I will want to run those embeddings again. But if they haven't, I'm perfectly happy having the corresponding embeddings stored somewhere. So let's take a look, and we'll pause after this section to answer some more questions as well. But let's take a look at actually applying some of these things that Ronnie has talked about. So the first thing, as I mentioned here, we're going to actually take the text in all of these different records, and we're going to send it off to an embedding model, and it's going to send us back the corresponding vectors. So we need to store those vectors somewhere. So we're going to go into File Manage Database, and we're going to add a new field that I'm calling note_embedding. And I'm going to follow the advice that we've been giving here and make that a container field. Now you could, in fact, like we mentioned, store it into a text field, but we're going to store it into a container field. So add a new field, note embedding, choose the type of container, and you see now we've added note embedding. The reason I'm doing that now is because we're going to go in and we're going to create another script that is going to run a vector embedding, or create the vector embeddings for us, and we need to have a place to put those. So I'm back in ScriptMaker, and I'm going to create a new script, and I'm going to call that script something super clever, embedding note data. All right, and just give it a quick little save. And so what I'm going to do is, so this is kind of where we get into that. This is one of the script steps, by the way, that you have to have flipped the switch, so to speak, or configured your AI account or run that script step prior to this. So this is one technique. I wouldn't say this is the best practice. It just fits well for the purposes of our training here today. But I'm going to perform that script, so I know for sure that I have run that. So here we see that when a user executes the embedding note data, that in fact it's going to make sure that the account is available by running that script. So then now is where we come into make our decisions. You notice that we have two of them here. Ronnie just went through insert embedding and found set. I'm going to choose the option for found set here because we're going to perform this against a found set of meeting data. So I'm going to double click on insert in found set. And the first input that you see is the account name. And that, just as a reminder, is the account name that we established in the configure AI account. And just as a reminder, the one that I'm using is sample account. Okay, just enter that as text. And the embedding model, which is also text, is the name of the embedding model that you're communicating with. So for example, in our case, if you noticed on the slides that we just shared that there were 3 supported embedding models over at OpenAI, I chose to use the one that's called text dash, and you're going to need to get the syntax correct. So let me just make sure I don't fat finger this, and I'm going to give you some pro tips after this as well too. So text dash embedding dash 3 dash small. And if you're watching this as a recording, you might want to make sure that OpenAI has not updated those names, or or change the syntax of this. So at the time of this presentation and recording, currently text embedding 3 small. So why did I choose small? Because we have a large one and we have a legacy one as well too. The small version of the embedding model that's currently available will be adequate for the task at hand, which is embedding our notes field. So with that amount of text, and the use case that we want to do is do semantic search against notes, this is a perfectly adequate model. And what are some of the determining factors that I'm using there? Well, first of all, this smaller model has fewer output dimensions than the larger one, and that is not a trivial thing to consider. Because, for example, the large option has the same max tokens, the same similar capabilities, I guess is a good way to put it, as the small one, but the small one is 500% cheaper. So, for example, the costs when you're using OpenAI are $20 per million tokens. And to really get, wrap your head around what a million tokens is, it's a ton of embeddings that you can perform there. But as we're going to, well, I'll give you a little bit of an idea of how much data is actually one, note field token, so you get kind of an idea. But the idea is here, this is perfectly capable in the metrics that we care about for this use case. It's adequate to large, and it's considerably cheaper than large. So that's why we're going to make that, we're going to choose this one in this case. So that again is the text-embedding-3-small. Now, there's 2 things that we have to do. We have to tell it where is the data that we want to vectorize. And that's where I hit that specify button there and I choose note. So that's the note field that I just showed you on the previous screen. And then the reason that we created the new field, which was the note embedding container, if you recall, was because we need to now store it somewhere. So really what's happening in this script is we're taking the data that's in the note field, we're sending it up to the OpenAI model, and then the model is returning back vectors, and then we're going to store those vectors here in the note embedding. And the replace target contents, if you recall, Ronnie was talking about, it's actually quite useful if like the note field is updated frequently so that it'll replace the embeddings that you previously had. And there's really no reason, if you deem that it's necessary to do embeddings again, there's really no reason to save the previous ones. I mean, there might be some edge cases, but so the rest of these the parameters we're gonna leave unchecked, and we're gonna save our script. And then what we're going to do is go back into the meetings layout here, and I'm going to just do something. This has no functional benefit whatsoever, but I'm just going to show you what it looks like when we, hold on, let me pull over the fields pane. So I'm going to just show you what these actually look like. So I'm going to grab the note embedding container, and I'm just going to throw it right next to this one, just so you guys can see what actually happens there. So here we are in browse mode. Nothing up our sleeves. And instead of doing all 100, because like I mentioned before, there is, there could be cost involved, I'm just going to create a found set of, let's say, just all the meetings that were for conference room 1, for example, because we did choose the found set option. So we're going to go, now that I've created the found set and I've got our field here so that you can see this, I am going to run the script here. So let me go into embedding note data, and let it do its thing. There you see, we just got a message, and now we notice that there is a file, a binary stored in here, and it's the same for all 24 of these records in this found set, but not for the ones that are not in the found set because of the option that we chose here. This is not, there's no functional benefit to seeing these, but if you want to export these out and find a compatible editor that you can open them up with to satisfy your curiosities, much like Ronnie said that he had done, feel free to do so. But since there's no functional benefit to this, we're just going to go ahead and delete that now that you've gotten to see what it looks like, and we'll move this note field back where it was before and go back into browse mode. And at this point, really simple there. We're going to pause again for some questions.
All right. So I think someone has asked if we could demonstrate how the embeddings look in text format for curiosity. And I think in the interest of time, I'm going to say, go up and do it yourself to satisfy your curiosity. That'll give you some experience using these tools.
And as a spoiler, it's literally just a sequence of numbers.
Yeah,
It's plot points on a multi-dimensional graph of meaning. So it's not too fascinating, but actually, I don't know, it's pretty fascinating. It's just like XY coordinates would plot something on a 2D, uh, 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 I guess, chart. These are tons and tons of those that will do the same thing in a multidimensional space.
All right. Next question is this is a security related question. I think it's really important. So the statement is, I'm guessing that if I disallow access to certain tables or records for certain users, I should also disallow access to the embeddings relevant to those records.
Yeah, and they will be a field in that same table. So if you're already disallowing all fields in that table, those permissions will go along with it. But yeah, it totally makes sense that if the data is sensitive to certain users, then the corresponding embeddings would be as well.
Yep.
Yeah, and just
Agreed.
I think one more question right now, and then we'll keep moving. And that is, how do all of these script steps and functions work with WebDirect? Especially since WebDirect can be kind of weird about container fields.
That's a great question. It should work perfectly fine, just same way. You remember that most of the time, you're not displaying the container field, right? Cris showed it there just for the interest of satisfying curiosity, but you're really not displaying it most of the time. And what's really happening behind the scenes, especially when you're generating these, it's really an API call that's happening, which is really interesting. This is the first time where we've got script steps and functions even that are performing API calls. So for the most part, this is most the things that are happening beyond that are really just regular FileMaker operations, and WebDirect works perfectly fine with this.
All right, and I lied. I'm going to ask one more question. Is there a way to perform the embedding as a field calculation or auto enter calculation rather than as part of a script?
Yes. So you probably remember I mentioned that there's 3 ways of generating the vector embeddings, right? 2 of them are script steps. One of them is actually a function, and you can absolutely use that function anywhere. You can use any calculation, right, or calculation engine. So you could potentially use that function inside of the auto enter for field definition to make sure that it's always updated or something like that. I'm not saying that you should use it that way, but if you wanted to, you can absolutely do that. Just remember, it is an API call.
Okay, so we did all of that. We created those embeddings so that we can perform a semantic search against the vectors. So before we actually implement that into our file, Ronnie, you want to take folks through what the supported script steps are that were introduced in the new version?
Absolutely. All right. So yeah, once again, you've got your AI account set up, right? You've created your vector embeddings. So now you're ready to do semantic find in your application. So the way to do that, right, at the start of the show really is this one script step called perform semantic find. As the name implies, that's exactly what it does. It allows you to search through data for similarities. So it really is, it's going to perform a semantic search based on the vectors that were generated and using one of the 3 methods that we've mentioned, allowing you to use either natural language or comparing vectors to vectors to find pieces of information that are similar to one another. So when you're setting this up, when you're setting up this script step, you've got several options over here. We'll walk through these one at a time. The first one is query by, and query by gives you 2 options. You can query either by natural language, or you can query by vector data. We'll talk a little bit more about this particular option in a second. But again, you can use either text for natural language, or you can use actual vector embeddings. So we'll talk a little bit more about it in a second, but let's look at the other options first. You can set here which set of records that you want to perform the search on. So record set allows you to specify the range of records that you're going to be searching through. So you can specify either all records in the table or only the current found set. And this is very useful in situations where you want to restrict the search into a particular set, or you want to perform this on top of another previous search. The target field specifies where the vector embeddings are, the ones that you're going to search through, right? So in our case, we've got a container field that contains that binary representation of those vector embeddings. Return count is the amount of records that you want the script step to return after doing a search. Now remember that when you're doing a semantic search, you're searching for similarities. This is not an exact match. So whatever amount you specify here is the amount of records that it's going to return. The default here is 10. If you want any number other than 10, 5, or 15, this is where you would set that up. Then you got two other really interesting options here, which is the cosine similarity condition and cosine similarity value. They work together. So cosine similarity condition allows you to specify conditions that must be met, right, within the cosine similarity threshold. So either greater than, less than or equal to, and things like that, or ranges for that cosine similarity. And the value that the cosine similarity condition is going to use is specified here in the cosine similarity value. Now, we'll talk a little bit more later about cosine similarity, but the values range using cosine similarity range from -1 to 1, where -1 is completely dissimilar, 0 is no association, and 1 is highly similar to those. All right, so now that we've got those other options, let's talk a little bit about that first parameter, right, the query by. So when you're searching, when you're doing a semantic search, you're literally searching, you're comparing vectors to vectors and seeing how similar one vector is to the others. So using one vector as your criteria, comparing it to all the vectors in your records. So that's all, it always will be a vector data. So if you already have your vector embedding that you want to search by, right, the source, the criteria you want to use, you can choose query by vector data. So you're providing a vector embedding as your source to search through others. Now, it might be that you have users who are typing something in, right, in which case your vector embedding doesn't already exist. So you're going to have to take whatever the user types in, there to search, convert that first into a vector embedding so that it be searched for. And this is where query by natural language comes into play. So in order for you to remove the additional step of having to create a vector embedding for the search criteria, you can simply choose query by natural language. And here, when you choose that, you'll get additional options that'll show up: count name, embedding model, and then the text, right? You'll see a similar theme coming on here, right? So what happens behind the scene is whatever text gets provided here will be converted into a vector embedding. How? We'll use the account name, right, for the account that you use for the configure AI account, and whichever embedding model you want to use to create that. So behind the scenes, this script step is going to do two things. It will convert, if you choose natural language, it'll take the text, convert it into a vector embedding, and then perform the search through all of those. That way you don't even have to store the vector embedding of what the user typed in. We'll do it behind the scenes, making it a lot easier for you, which is pretty cool.
All right. Well, now that brings us to the real meat of our exercise. Now that we've prepared our file to be able to, or so that it has vectors, we're going to search against those vectors using the perform semantic find. Then I'm going to show you how we can integrate cosine similarity and what that means. And then we'll open everything up and we'll have a big discussion to close things out. So for those of you that are following along, now we're really getting to the magic. We want to allow users to be able to perform a semantic find. So we're going to set up a script to do that. We're going to go into ScriptMaker, like you see I've done here, and I'm going to create a new script, and I'm going to cleverly name that one perform semantic find. All right. And within that script, you guys can probably guess what I'm going to do here. In order for the perform semantic find to work, we need to have configured our account already. So this is, again, this is not necessarily best practice by any means. This is just the tactic that I'm using in this case. And that is I'm going to run that script first to make sure. So if I don't need to do embeddings, or I haven't turned on or I haven't configured the account at the beginning of my session, before users can start leveraging semantic find, we want to make sure that we configure that account. So we've got that in here as well. And then I'm going to go over here to our artificial intelligence group, and I'm going to choose perform semantic find. This is the script step that Ronnie was just going through. And you notice that we have various different decisions to make. So first of all, I'm going to do the, before we get to the gear icon, you'll notice that we have the options between query by natural language, which you see here is set as default. I'm going to keep it as that because that is appropriate to what we're doing here, because the users are actually going to enter in plain English text that they want to search against. And then we need to tell it what account, and you guessed it, this is going to be sample account. That, of course, is the name of the account that we configured in the configure AI account script step. Make sure I got that syntax right. And the embedding model. Now, this is the same embedding model. This is actually very important. We selected the text, this one here, text dash embedding. Let me make sure I got that. Dash 3 dash small. Okay. We selected the text embedding 3 small embedding when we were embedding the notes values. So we've already created those embeddings. And so for the embedding that happens on the fly, because in this case, we're using the natural language option, we need to use the same model. So models have specific vector outputs. And if you're going to compare the vector outputs, they have to come from the same model. Extremely important. And we will be comparing these. That's actually what cosine similarity actually is. Actually, cosine is one of the options that models use to create vectors. And so we need to have them both be cosine, and we need them created from the same model. They have to have the same dimensions is really what is what the most important part is there. Okay, so then I've got my model selected. And so now what we're choosing is text. And I don't have a field for that yet. So what I'm going to do is I'm going to select the text. And over here, you see that it opens up a specify calculation dialog, but I'm going to create a field. This is going to be the search field that the users are going to enter their search criteria into in order to execute the perform semantic find. So let's go into, over on the left-hand side, we're going to go to manage database inside the meetings table, and we're going to add a field called search field. Because in fact, that's what it's going to be. We're going to hit create, and I'm going to add one more important step here, and I'll describe why this is important in just a little bit. But I'm going to make this a globally stored field. Because this is more of a utility field, this isn't something that's going to be storing data, and there's some other characteristics of a globally stored field that we're going to leverage here in just a moment. So just looking at, so now I'm going to make sure to pick that field. And if I hit OK, you can kind of see what we're doing here. We're saying use the sample account, specifically the embedding model, to embed the value that we put inside a field, this field right here. And we want to perform that either against all records or a found set of records. I'm going to say all records in this case, but just a really important point there. That is a very important decision to make. If you leave this as the default all records, then the vector similarity comparison needs to be run on all records in your table, which is fine, say in this file where we've only got 108 records. But if you're in a database that has tens of thousands of records, this feature is not going to be performant, and it may not make sense to evaluate such a large data set semantically anyways. So you should precede the perform semantic find script step with either a scripted find sequence, which you're all used to doing, or even like a go to related records, which will create a found set of data or a limited set of data to perform the find against. That will narrow down the found set before performing the semantic find. So for example, let's say in this case, we could have narrowed it down by like a date range of meetings or something like that we wanted to search against, or a certain month or quarter, or maybe even just a certain location. But we're going to leave it as all records for this exercise, but you really should consider establishing a narrower found set to perform a semantic find across as a matter of best practice. Now, you'll notice here in the gear icon, we are choosing all records. That's the option that I just discussed. And I need to pick the target field. I'm going to select the note embedding. So when it says target, what field are we searching in? We're going to search in the vectors that we created in the embedding process before. And so this is that note embedding field that we created inside the meetings table to store those, which is the container field. And I'm going to leave these for the next set. Oh, actually, no. As Ronnie mentioned, return count. It is set to default, so if I don't check this, it's going to give me 10. But just so you can see what kind of control we have over it, let's just set that to 11, just so that we can get something a little bit different. And I'm going to go into the similarity condition in the next step here in a second. I'm going to really kind of dive into that quite a bit. So let me just leave the options that we have them here. And by the way, just a quick note on return count. It's not like creating a find, like a standard index find or lexical find in FileMaker where it gives you back everything that matches, because technically in a semantic search, every record in your database matches your semantic find. They just have levels of similarity. So you could get every single record back and it could give you almost no similarity at all. So to really kind of change the difference between, in your mind, between record return found set from a search or return count is, they're kind of really, fundamentally different concepts here. Okay, so back in the file quickly, I will go into layout mode real quick, because that field that we just added, I want users to be able to search across it. So there's the search field. I'm going to drag it here, and actually I'm going to make it just a little bit smaller, because just from a UI standpoint, I want it to I want it to stay contained within the notes tab. So I'm going to make it 14. If you make it 14, you'll see it gets a little bit smaller. And I'm going to make it the full length of the note field so users can type phrases in there, which, by the way, is quite common for semantic search. And then I'm going to leverage this very convenient button. Oh, no, actually, yeah, let's anchor this to the right edge. There we go. With the search field selected, let's anchor that to the right edge. And now this button that just happens to be there without any action assigned to it, when we go into button setup, I'm going to, I could change this to search, and I'm going to choose perform script. And yes, we're going to perform the semantic find script. And of course, that script will start by performing the configure AI account script as a subscript. So now we have everything set up to actually perform a semantic find. So I'm going to save my changes, and we get that little weird FileMaker behavior there. Let's just make this full screen. And now I have my search field available. Let me go and show all. And now I can actually test this out. So note what I'm going to enter in here in a second. So operational efficiency and performance improvements. Okay, so first of all, this isn't keywords. These are concepts. And I've combined different concepts together. So I want to find any meeting where the concepts around operational efficiency and performance improvements were discussed. And that is not a keyword search. And I'll show you a test of that in just a second. So a quick search, I've just performed the search, and you see that I have 11 records here. And I just want to show you, I have another version of this set up. Let me show you something that I prepared for you guys, just so you can see. So oh no, that's not the version I want. My bad. Sorry about that, everyone. There we go. Okay, so here, if I do operational efficiency, let me just copy and paste that real quick. This is not in the data that I shared with you, but I thought this would be an interesting way to look at this. So here we are. I'm going to do the. All right. Actually, I probably should have added the field on there. So, anyways, the idea is when we're searching for. Oh yeah, I'll just do it real quick. Sorry about that. Search, add that one right there. Boom, boom, boom. Got it. And add that to our script so you guys can see. And that's not in there. Okay, never mind the whole thing. So the point is, you'll have to trust me on this one. Sorry, we're a little short on time, so I'm not going to go down that rabbit hole. But the point is, I had highlighted some of the areas that actually match. So the thing with semantic search is you're not looking for the keywords that match. These are concepts that match. So we're finding in these 11 records, we're finding discussions about operational efficiency. Like here you see potential efficiency gains from automation, and then performance improvements. So Rachel proposed implementation starting with a pilot program, and so on. So really, to kind of wrap your head around what semantic searches are, these are kind of a fascinating and completely different way that we've looked at our data that we're storing in our FileMaker databases. One thing that's really important to know here is that it's giving us 11 record count back because we told it to. Remember, the default was 10, and the order is really important. So it's kind of sorted or ordered in the order of the most semantically similar, that would be this first one, to the least semantically similar. So in the next exercise, I'm going to give you a little bit more visibility on that as well too. So you can type any kind of searches in here. I would also suggest maybe using the search term risk mitigation and contingency planning, which is another one I was going to go through, but in the interest of time, I'll let you guys all do that on your own. And there's a bunch of records that'll come back and you can read through them and maybe in your own exercise, try to find what it was conceptually or semantically or from a meaning standpoint that matched these different search terms. It's kind of a fun little exercise for you. So now we've go ahead.
Yeah, so I just want to sort of double click here. So I'm just ask a question. Is it possible to order from the most similar or the best match? And if I heard you right, Cris, you said that's what happens automatically. The record, if after you perform a semantic search, the results are sorted by similarity and the first record will be the most similar.
That's correct. Yeah.
That's correct.
And if you don't want to do that, like if you're looking for the least similar, which actually there are use cases where you're trying to find things that don't discuss a certain term, let's say in a meeting, you would need to have some visibility onto what the cosine similarity value is. Right now, that's behind the scenes, but Ronnie, tell us a little bit about a function that would help us leverage that and maybe even sort by that value if we want to do a different one.
That's a great segue. So yes, Cris mentioned that when you run the perform semantic find script step, the records are already sorted by similarity, right, of those resulting records to the criteria. But how we measure that, right? There are different ways of measuring similarity in this vector space, and so the way that we can measure that in the FileMaker platform that we use is there's a method called cosine similarity. And we've actually created a function in here that allows you to calculate that individually. So the cosine similarity function gives you the similarity between two vector embeddings. So again, while there are other formulas, other equations to calculate the similarity between two vectors, there's the Euclidean and dot products and others like that. We've chosen the cosine similarity one. It's a very popular one. It's very performant. So for vector embeddings, the cosine similarity gives you let's say a useful measure to find out how similar two pieces of data are likely to be. The result of this calculation is going to be a range. It's a number between -1 to 1, both inclusive, where values that are close to 1 are highly semantically similar. Values that are 0 have no association or no meaningful similarity, and -1 or values that are close or including -1 indicate dissimilarity, so complete opposites. So if you wanted to find things that are opposite or outliers, for example, you want things that are closer to -1. So you can use this function to calculate those between two particular vectors. It's important because Cris had mentioned earlier about using the same model. This is very important here because you want to make sure that the vectors that you're going to be comparing are the result of using the same embedding models. You want them to be the same size and dimension, but they're also created by the same embedding model, because those dimensions, even if they are the same, but they're created by a different model, they might have different concepts, different contextual semantic meaning in there. So you want to make sure you compare, right, apples to apples, oranges to oranges, basically is what we're saying here.
Okay, so let's bring it on home here. I'm going to actually apply the cosine similarity function. I want to actually show people what the cosine similarity values are. I'm going to place a value right down here in the bottom so that as users go through the different record set, they can see which ones are more similar and which ones are less similar. Even though they're sorted that way, they can actually manipulate it or maybe even set their own value.
Yep.
So,
hey, Cris, can I pause right there? Just so everybody notice, on the top left where you have the found set, you'll say it literally says found set is sorted. Right? So when you do the performance find, yes.
Oh,
Sorry,
that's
go ahead.
yeah. So it is sorted, not just reordered. Okay, good.
Yes.
I'll use the sorted language. I just learned something. Okay, so it is a calculation function. Should we create a calculated field in the interest of time? Spoiler, no, because I'm going to show the cosine similarity for the search I just did, which is just meaningful to me as a user in my session. So other users aren't going to find anything meaningful if they see a cosine similarity on their records, and they're not going to find it useful if they see it on records that aren't part of a record set that is returned to them when they do a semantic search. So instead, I'm going to use a feature that was introduced. Ronnie, what version of FileMaker was
2023.
insert layout calculation?
2023.
2023. So if you haven't used insert layout calculation, this one's actually perfect for a couple of different reasons, because it'll dynamically display the values directly on the layout without the need to create additional fields, which is great. It's evaluated in real time when the layout is rendered, and it will update every time the fields that are referred to it change. And in this case, that's perfect because we want it to update every time the search field is changed, meaning every time somebody does their own search. And also, because the search field is global, that means it's specific to, those values will be specific to only my session, and I won't be confusing users by them seeing values in their own. So this is why we're selecting the insert layout calculation. So first, let me find cosine similarity. And you'll notice we just have two inputs here. We have the two different vectors that we want to compare. Now, we already know the second vector because that is the notes embedding, because that's what we're searching against. So those are the vectors that are in that search field. And now this first one is going to have to be the vectors for, and this might be a little bit confusing, but the vectors for the value that's inside the search field. So how do we get the value inside the search field? Well, Ronnie mentioned before that because we chose natural language as the input, when we do the search, it's going to take that search criteria and it's going to throw it up real quick to an embedding model and come back with vectors that it does its own comparison with. So we have to emulate that same thing here, but in order to be able to extract the embeddings from a value, we're going to use the previously mentioned get embedding function. So get embeddings, Ronnie, what's the cool trivia about the get embeddings function? It's the first time ever
It's the first function that ever makes an API call. It's really cool.
Yes, and so I'm gonna accelerate through that. We did talk about get embedding earlier in the session, and so it is actually going to perform its own API call. So we have to have it give it access to an account. You guys are probably starting to see the patterns here. It's the account that I set up in the configure. And this is so important that we've mentioned it a few times now, but it cannot be mentioned enough. Set embedding or text embedding 3-small and then the last one is the text. This is actually what we want to search on. And so of course, in this case, we're going to use the field that we just set up, which is called search field. So we're comparing the vectors from the get embedding from the search field. Oh, thank you very much. That would become a real problem in a second. And to the embeddings that we already created for the notes. So that's really what semantic search is. It's just comparing the vectors and determining a numeric similarity between them. Now, this is very important. It has to be numbers. That's what the calculation result is. Because if you remember, Ronnie was mentioning that the numbers can either be a range from -1 to 1, and they're inclusive of -1 and 1. And remember that 1 indicates the highest semantic similarity, 0 indicates no similarity, and -1 indicates dissimilarity. So anything below 0 is actually saying it is not similar. And so sometimes you might be looking for something that is not similar. So so let's go ahead and I think I'm going to just do, oh, there it is. Let's put this down on the bottom, make it a little bit wider, and just like merge fields. Oh, I probably should have done that little return there. Just like merge fields, you put those on your layout, they kind of bleed over a little bit. So let's just do bottom right instead of top. Okay. All right, so now I go back into browse mode. Let me just get rid of this little weird FileMaker behavior. And you'll notice that there's already numbers in there. Why are there numbers in there? Well, because I had just previously done a perform semantic find where FileMaker had gone and created these cosine values for us. So now what I'm really doing is I'm showing those values. So so you'll notice that they go from the most semantic similar. And by the way, this isn't technically correct, but at this stage of learning embeddings and cosine similarity, you can look at this number as percent similar. It's okay. It's not technically correct, but it's okay to do that. So you're looking at this one as 47% similar to the search criteria. This one's 42 and so on. I can tell you just from working out in the wild, 0.3 similarity is not actually very useful similarity. So you might want to establish a threshold. You might have done some experiments and determined that in fact anything that's below a 0.3 is not useful for whatever your work task is. So quickly, I can show you how you can actually constrain your found sets to only the level that you find meaningful or that threshold. So we can say greater than or equal to, and then you say cosine similarity value. And I'm going to say only give me anything that is only give me anything that is we go back, we'll save this, that is semantically similar. And now if you notice, I'll run that script again, and I only get 2. So this tells me that only 2 of them are above the acceptable threshold that we've determined. Now I could go in and apply a hidden condition using that same threshold. So hide when the value is lower or below 0.4. So that way, when I look at all the other 108 records, I'm not going to see a value. So it's only meaningful to our found set. And so with that in place, now we are able to see our cosine similarity values, and per the individual's question, we could sort on those if we like, and sort in some other kind of meaningful, maybe you want to invert it and do it least similar to most similar, for example. So that, and apologies for a little bit of the express version there, but we want to make sure to get that in. So that concludes our hands-on portion of this, and we'll get into conclusion and next steps here. Oh, and actually, just one quick pro tip. There's another link that Rosemary's going to share. It's to a custom GPT that we've created for this session. For those of you that have an OpenAI account, which you'll need because you're going to need that to get your API key, you can go to this link, and 24 hours a day, you can initiate a session based on this GPT and ask it any question that you want about anything that we've covered. So if you didn't get your question answered today, you can ask it in here. And also, by the way, you can actually put in what your use case is, and it will guide you through how you might want to set that up, and maybe even give you some suggestions on what your FileMaker scripts might look like with some level of accuracy. So have fun with this. And Rosemary, I'm going to kick it back to you to bring it on home.
All right. Well, thanks so much, Cris. Thank you, Ronnie. We just got a comment in the chat that says, thanks, this worked great. So yay, I'm so happy to hear that at least one person was successful in the demo.
Yeah, awesome. That's great.
Yeah, I hope all of you who tried to follow along were successful. And someone just said that we need to pay Cris more so he could buy an actual, not cheesy cup of coffee. And I am going to veto that suggestion because I think Cris is one of the few people in FileMaker Claris world who is a bigger Packer fan than I am.
Go Pack.
In fact, if I look up at the bookshelf right in front of me, there is a cheese head on the top of that shelf.
We got numbers.
So again, thank you everyone for joining us. Thank you for filling out the poll. And I hope to see you all in 2 weeks when we have Women Ronnie with me to talk about. That was my husband Dave making a cameo. So in 2 weeks on November 7th, where we will be talking about setting up a local LLM. And that will be, I think for that one, Wim is going to demonstrate, but that will not be a follow along workshop like we did today. And just a final reminder,
this is being recorded, much to your chagrin, because now everyone's got a shot of you and a cheesehead.
All right. Thanks again, everyone. Have a great rest of your day.
Thanks, everybody.
Thanks,
Cheers.
everyone.